Hello and welcome to Game Titan. Today I wanted to explore building this fractal in Scratch. As you can see, it looks a little bit like a leaf or a fern and was invented by this mathematician in this book, Fractals Everywhere. A fractal is a shape that is self-similar. So if you take a closer look at this fern image, you can see that the whole image looks a bit like a fern, but if you take any one of these branches, it sort of still looks like the whole image. And then within each of the branches, if you take any one of its leaves, it still kind of looks like the whole image, and within that you have a bunch of smaller leaves that look like the whole image. And the neat thing about these is that they're pretty easy to generate mathematically. This one looks like it's a little bit more complicated than the Sierpinski triangle that we did previously, but luckily this Wikipedia page has some code in it. There isn't Scratch code, but if you look at the code, you can see that it's assuming that your programming language has a turtle and a pen and the ability to put the pen up and down. And luckily, Scratch also has that ability. The way that you add it is by clicking on this block over here in the corner of your Scratch program and adding the pen extension, and you will then get some coding blocks that let you put a pen down or pen up and use your sprite as a turtle that will drag a pen around on a piece of paper. So hopefully we should be able to just convert this code directly into Scratch code and have it draw the fern. So the first step here is to put the pen up, as you can see here. So we'll do that by adding the one flag click block, and in Scratch you want to erase all and making sure that the pen is up. Then after that, it looks like there's two variables here, x and y, that we'll need. We can create those, x and another one, y. And the first thing that we do is we'll set both of them to 0. Set x to 0 and also set y to 0 as well. Then the next step is going to be to loop, and in this case the code that we're looking at is looping 110,000 times. So I have no idea if this is going to work, but we can stick 110,000 into a repeat block over here. Then we'll say pen.goto, and I don't know if these coordinates are reversed from the way that Scratch is, but there is a goto block in Scratch here, goto x and y, and here we're going to go to 65 times x, so we can add that in. 65 times x, like that, and y is 37 times y minus 252. 37 times y. Hold on. It's 37 times y first. Remember your order of operations. 37 times y first, and then all of that is going to be minus all of this minus 252. Multiplication before subtraction. 52. Then we'll pen down. That will be in the pen area here. Pen down and make a dot. So in this case, I do not know if you just put the pen down and bring it back up in Scratch, if that will actually create a dot or not. So we could try it by hiding the sprite and clicking this, and it does not look like it does. So one thing that we could do, since this is making a small dot, we can go into the Costumes tab and get rid of the cat, and then create a small dot like that. We'll want to make sure that it's very small. Right now you can see it's 5 by 5, which is much larger still than we want it to be. We can keep shrinking it until it's closer to 1 by 1. Maybe something like that. And we'll want to make sure that it's centered. I think the center is over here. It's going to be hard to move over because I made it so small. Am I able to grab it? I still have to zoom in some more. There we go. We can move it right there so it's in the middle. And unless we want a purple fern, we can change the color here so that it's a bit more fern-like. We need to select the dot first. Yeah, it's kind of like a fern-like green, hopefully. So now that we have this dot as our sprite, instead of doing pen down and pen up, what we can do is stamp. And that will create a little copy of the sprite using the pen. Let's try that. It's hard to see where it is, so maybe we should keep going first. Then we need to pick a random number. This in Python is going to give us, I believe, a random number between in Python. It's going to give us a random number in the range 0 to 1.0. So this square bracket here, make it a little bit bigger. Where'd it go? Here we go. So the square bracket here means that the number that comes out could potentially actually be 0, and this rounded parentheses on the other side means that the number that comes out can be almost 1, but not quite 1. You're never going to actually get 1.0 out of this function. So in this Python code, and if you saw that spinning beach ball, I actually have another video about game loops that goes into why that happens. In this function here, we're saying r times 100. So we're expecting that the number is going to be between 0 and 99, I believe. And then we're saying if r is less than 1, which is very unlikely, it's like a 1 in 100 chance that it'll actually be 0, then we set x and y to this. If it's less than 86, which is the bulk of the probability, anything from 1 all the way up to 85, we'll set x and y this way. Anything less than 93, so that's what is that? 4 plus 3 is 7% chance, and then last 7% chance is this one. So it looks like if we get the translation of this random number wrong, and this is actually from 0 to 100, It won't be too bad. This thing will happen a little bit more than this. At least that's my hope. So let's do that. Let's add this random number here and set it in this variable called r. So we'll need the variable. We need the variable called r. And I see that there's also two other variables. There's one called xn and one called yn. So let's create those two. Xn and yn. And so r we said is going to get set. This is right after we stamp, I believe. Right after we stamp, then r is going to be set to random number between 0 and 99. 0 and 99. And then xn will be set to x and yn will be set to y. We'll set xn to x and we'll set yn to y, like that. Then here's what we need, where we will need our if statements. The first one is if r is less than 1, and that should just be one of these. If r is less than 1, over here is less than 1, then x will be 0 and y will be this other expression. X set 0 and set y to this thing here, 0.16 times yn. 0.16 times yn. Yn is over here. Otherwise, if r is less than 86, so we'll need another of these blocks. Otherwise, if r is less than 86, then we'll set x to this thing here. So this is something times something plus something times something. The binomial. Just learned that recently. 0.85. So we'll say plus. Last thing that we'll do is this plus. Let's get rid of this so we don't get confused. And then it's something times something plus something times something. And it's 0.85 times xn. 0.85 times xn plus 0.04 times yn. 0.04 times yn. And then here, this has 1, 2, 3 things that we're adding together. So this something times xn, something times yn, plus this constant 1.6. So we'll need 2 plus signs in here. Plus signs. It doesn't really matter whether you put this over here or this over here. Drop it there. And then the first two are multiplying two things together. So it's minus 0.04 times xn. Here's my variable. Xn plus 0.85 times yn over here plus 1.6. And now, actually, that I'm looking at this code, I didn't understand, well, I'll admit it, I didn't even read this part of the Wikipedia page earlier, but now I can see what's going on over here, where this is 0.85 times xn plus 0.04 times yn, and that corresponds to here. So this is representing this 0.85 times x plus 0.04 times y plus 0. And this bottom part over here is minus 0.04 times x plus 0.85 times y plus 1.6 minus 0.04 times x plus 0.85 times y plus 1.6. And that is all there is to multiplying a matrix times a vector in linear algebra. So we have 2 more cases to go. Oh, and we can see that all of these variables are jumping around like crazy. How exciting. This one is going to be similar. Where'd my code go? Here we go. Same structure as before. Something times x plus something times y, and same thing with y. So our constants are 0.20, and this is the case where r is less than 93. So let's not forget that part. R is less than 93, and then our coefficients here are 0.2, and negative, let's make sure we catch that part, negative 0.26. I wonder if the space in the middle is going to cause problems. And then for y, that's 0.23, which we can just copy and paste over, and 0.22. And the constant is also 1.6. And that leaves us with our last case, which is where r is anything else at all. So in this case, we don't actually need this if statement anymore. We'll just put it in the else. This is for all other possible values of r. And here it's the same structure again. Some constant times x plus some constant times y, and then y is some constant times x plus some constant times y. And I'm sure if we look at the matrix of numbers up above, it'll be the same. Negative 0.15 and 0.28, and indeed here they are, negative 0.15 and 0.28. So you can see here's the probabilities. There's 1% probability of stem. That was the first branch that we did, first if statement, and then 0.85% of smaller leaflets, 85% chance of smaller leaflets, 7% chance of largest left-hand leaflet, and 7% chance of largest right-hand leaflet. So it should actually be possible to play around with these numbers after the fact and see how that changes things. So let's make sure we copy the last set of numbers over. Minus 0.15 goes here. 0.28 goes here. Let's make sure that was a plus. It was a plus. 0.26. And this one is 0.24. Given that this is still running, I think this might take a long time to draw. But we shall see. And then finally this number is 0.44 over here. So that is actually all the code that there is. Let's hit stop and start and see what happens. So nothing's drawing on the screen right now, and I wonder if the reason is because the costume might be too small. That is my first guess. Indeed, that seems to be right. I'm gonna see what's happening already. Right now it's 7 by 7. 1 by 1 was clearly too small. Let's see if we can get by with something that's barely 2 by 2. That's 1 by 1. Maybe zoom this in a little bit and keep dragging it in there. It's, I think, just slightly above 1 by 1. See if this is visible. It is. So we can see that this is drawing something, and we can't see the stem, unfortunately. So what we may need to do is zoom this entire thing out. And I think that the way to do that would be here, where we're drawing. Rather than going to this spot here, let's make a new variable called scale. Although I'd love to have this variable be one that we can drag and make that like let us change the size of this thing in real time. So maybe what we can do is have this variable be a percent scale, where 100 represents the normal standard Barnsley Fern, and there's the spinning icon of death again. Barnsley Fern. The percent scale 100 will be the, oops, I did not mean that to be a global variable. It said that global variables are the root of all evil. Percent scale. So let's use a local variable. That's the ones where we have for this sprite only checked. We'll set percent scale and we'll set it to 100. Set it to 100, meaning 100% at the beginning of our program over here. And then in order to get the x values to follow that, what we want is, if percent scale is set to 100, then we want this go-to to be the same as it is now, 65 times x. If percent scale is, let's say, 50, we'd want this to be half as big, which will make it half as far away from the middle of the screen, the origin of the coordinate system in Scratch. So that means that as percent scale goes down, we want this number here to also go down, and so that will mean that we want to multiply this by percent scale. Because when percent scale, if you think about the extremes, when percent scale is 0, this will be 0, which is great. We want the thing to be 0% big and everything is always at the middle in the origin. And let's say it's 200, then we'd want this to be twice as much. So we'd be multiplying it by a bigger number and all of the numbers would be bigger. But right now what we're doing is we're actually making this 100 times bigger. So to cancel that out, we need to actually convert this percent into a fraction by dividing it by 100 first. So now if percent scale is 100, then this value here, this fraction here is 1. And so we're just multiplying this by 1, which is nothing to it. And so I think that's exactly what we want to do. And then we'll have to do the same thing here, where we'll take this whole number and multiply it by this fraction, percent scale divided by 100. Oops. There we go. And so we'll move this whole thing out and then move this expression back in, and now we should have this slider, and I can change the slider range to say 200, and that should let us make this bigger and smaller. But alas, when we do this, it works, but only for the future dots, not for the past dots. And this thing is so slow that I don't know if we're going to be able to redo everything in immediately as we're sliding this, but we can try. So the way to try, let's first of all get rid of all these variable updates, because we don't want those drawing to the screen. And then here, if we grab this whole thing and put it in a function and turn the run without screen refresh on in the function. So this is going to be called draw fern. And then here we will call it once and see what happens. This may freeze Scratch, so if it does, we need to reload the whole page. Oh, That is not bad at all. And if we change this, let's see, so at the beginning of draw fern, let's erase all. We don't need this anymore. See if that works. Interestingly, that even though this has without screen refresh, it clearly did refresh the screen in here. I'm kind of curious if we turn on turbo mode, which reduces the number of screen draws. What I did was I clicked shift while I was clicking the green flag. Let's see if this changes anything. It actually doesn't seem to. It looked about the same to my eye. I'll turn off turbo mode and play it again. Yeah, that looks about the same. So even though we have run without screen refresh turned on over here, clearly there's some kind of screen refresh going on. But this does look fast enough that maybe what we can do is actually crank this down. So let's turn this 100,000 into a parameter. This will be the number of iterations. That's the number of times that we're gonna damp the pen. So instead of putting the 100,000 there, we'll put it here, and instead of hard coding it, we will make a variable called iterations. We'll drag that in here and turn that into a slider 2. Change the slider range to 110,000 like it was before, and just to begin with, we'll set it to some small number. Hopefully that will then allow us to put this forever loop in here where we'll keep drawing the fern over and over again. That seems like it is working. And now as we change the size, we can see that the size of the fern does indeed change. Maybe in order to have a good screenshot for this video, we can create a nice contrasting background of some kind. Let's say, just pick some kind of red for now. And we'll need to, yes, need to make sure this is in background. So let's make this very big so that it will cover up the whole stage, and then center it, because things being just so. And maybe pick some color that, unfortunately this is not updating interactively, so it's going to be hard to see. Maybe if we stop the script, it'll update more quickly. A nice contrasting color to green might be some kind of reddish color like that. That looks pretty good. I wish I could make it a little bit more brown, maybe. A bit more orange. How about like that? It also makes the fern easier to see. Now, as we're adjusting the scale here, we can set it to 72. Looks like it causes the stem of the fern to be visible. 72, and we'll go back to the right here. We could even call this right Barnsley Fern. And let's set this percent scale to 72 to match what we found here interactively. Very slow. You can see that the dragging of this area gets very slow while it's running. So we'll set fern iterations, right, percent scale to, what did I say? 70, whoops. 72. There we go. And we don't want that in there. It's never going to change ever again. Oh, we already had a percent scale block. Alright, let's delete that. And there we go. Now we can maybe crank this up the way it was before. It takes so long to draw each time. You probably don't want this in a forever loop anymore, but you could put it back in if you wanted to play around, turn down the iterations and play around with this. And I think the other thing that would be interesting to do, maybe we'll actually do this now, is we'll play around with these probability parameters. So here we have stem and leaflets and left and right. So let's create some variables for those. So we'll call it stem threshold, because it's not a probability, it's like a boundary between different numbers. Anything that's less than the stem threshold will be using the stem transformation. We'll call it stem threshold, and Chrome does not like switching tabs right now. Small leaflets, let me remember. Leaflets, left and right. Leaflets, threshold, we'll say left threshold, and the right threshold. And so we want to set all of those up to their proper values. So we'll have stem, leaflets, left, and right. That's 1, 86, and 93. 1, 86, 93, and this last one is actually technically 100, but I suppose we're not actually using it, so we can get rid of it. We'll set those up, 1, 86, and 93, and then we will use those variables instead of these hard-coded constants. 1 is the stem, 86 is the leaflets, and left was 93. And hopefully everything should look the same. Famous last words. Oh, here, iterations is 0. That is not good. Iterations. Let's actually initialize iteration. Oh, I know what happened. Is it previously had been 110,000, and then I clicked on this. Actually clicked on it in here. That was very confusing. And that switched to 0. So this is a lesson to always initialize your variables in your code and not just assume on the values that are stored, because you might erase them. There we go. That's still drawing. And now let's turn this back down, something like that, and put the forever loop back in like that, and make it small enough so that it's updating quickly. And then what we'll do is we'll turn these into sliders too, by double clicking on them. And then I'm curious what will happen if we increase this. Oh, look at that. The stem got so much thicker. Look, we can do mostly stem. Or we can do no stem. That is neat. And then here's leaflets. So what if we have less leaflets? Fewer leaflets. That's interesting. This can almost go up to 93. So when it's 93, what this is saying is that the left threshold code never runs, because if R is less than 93, it'll run this leaflets code here, and then there's no other possible value of R where this code will run, because it's checking if R is 93 over here too. So we can see that that actually gets rid of the left side entirely. A little hard for me to see actually what happens. Like, I don't quite understand what the difference is between, say, putting this at 84 and putting it at 70 something. They look very similar to me. Maybe they are. So what I would suspect is if we crank this one up, left threshold all the way up to 100, that we're going to lose all of the right leaves now. That seems to be what happens indeed. And what's happening here is that once we get to this point, all possible R values are less than 100, and so this code will never run. So we can restart the program to get back our original values. We can leave these sliders in here because they kind of are fun to play around with. And maybe in order to make this just a more fun toy, we'll leave this value smaller so that it can refresh over and over again. Like that. It's possible to play around with these values and see what happens. Well, if you like this video, please click the thumbs up button and subscribe to the channel. Thank you for watching, and see you next time.